Hey, welcome to the Smarter Grid. I'm your host, Dr. Nate, and in this series we explore all the engineering and digital aspects of the power grid. So that's everything from relay protection, control, and automation to cyber engineering and communications. In this episode, we're going to talk about some tales from the field, specifically automated SCADA testing. So this was a little bit of a challenge project for us where we were tasked to basically look at testing hundreds of substations. So whenever you have one substation that you're testing, it's a challenge enough, right? But when we're talking hundreds over a finite time, that's even more challenging. So if you had to test out and check out a substation from end to end, right? You're checking out the relays, making sure that they're performing their protection logic accordingly. And then whenever you look at the integration from the station itself to some head-end control center, you have to go point by point and make sure that all those values and controls are going back and forth properly, right? That the values are matching. So if you had to do this manually, let's say we have our person in the field, technician, engineer in the field, Chris, as well as we have a SCADA control center operator named Emma. And she's out here able to remotely control and visualize things, right? During this testing and checkout process, Chris and Emma have to go point by point. Chris says, hey, Emma, I'm just forced a point of 20. What are you seeing? Let's say if it's for watts, megawatts, VARs, what have you. And then Emma says, hey, I'm not seeing 20, I'm seeing 2. And then you would have to make note, Emma and Chris would have to make note that scaling needs to move, right? Very painful to go do this one by one, as well as the station itself needs a test plan. So before you go out and can safely do this, you need to have a test plan in place to say what type of work and exactly what values are going to be forced and then what those values are, right? So what we were able to do with some of our software via our interdisciplinary team of power system engineers, cyber engineers, software engineers, all grouped together, huddled together in a room, we were able to come up with some really cool automation script where we were able to automate the creation of the test plan and the execution. So the test plan was actually able to take in the migration files. So this was a SCADA upgrade from a legacy SCADA system to a brand new ADMS, Advanced Distribution Management System. And then there was a migration file that we wrote some software that was capable of digesting. And because of this, we were able to find buku errors and then send that back to the migration team to help solve. And this code, this AutoGen code to create this test plan, also was able to take in the RTU config file for the station RTU remote terminal unit, and then boom, produce the station-specific test plan, right? And then we were able to create an actual test execution script that is able to take that test plan, run on the laptop in the field, hook into the RTU and be able to have software, basically our script, running on this laptop, talking bidirectionally to this RTU. And of course, this type of testing, all the test switches are all open to be able to safely operate, simulate an operation to the RTU. And the code here, also taking in for the execution, the SCADA historian file, right? So as I mentioned, traditionally, Chris is up forcing values, asking Emma, hey, what did you see? So our software here that's running on this laptop was actually able to take in the historian data as it is hooked in, able to force all these points, go pop, 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 pop. And then once it's done forcing, get this historian file, load it up, and then automatically produce some results. Did the point pass? Did it fail? Was the scaling off? And then the amount of savings here were really phenomenal. So looking at the test plan creation by itself, without any automation, we're looking at about 2.4 hours to do this manually, to compare the RTU config directly, point by point, very grueling work, to then compare it to the migration file, going point by point, saying, hey, do things line up? Do they match? Our software was actually able to create these test plans for 15 seconds, and then, for good measure, 10 minutes QC, right? Always have to have that QC, that engineer kind of review and QC oversight. And then, so this is the test plan creation. Now let's look at the execution, where on average, you're looking at about 40 seconds per point, right? And this is once again Chris manually just on the horn, on the phone, talking up to Emma. And then the automation script that's running on the laptop in the field is actually able to do this 5 seconds a point. So whenever you do all of this math, whenever we look at the actual savings, we found that we were able to reduce what normally would be like a day, day and a half long. We're talking 300 points per substation, let's say on average, to half a day, a quarter of the day. So some of these are big substations, right? And whenever you look at the overall savings of this, we were actually able to reduce or save, approximately 3,000 hours, which looks at, depending on the average, hour workday, 363 days, man hour, man woman days of actual work. So kind of the moral of the story here is when you have these types of challenges, try to get an interdisciplinary team on it. Make sure that things are being followed safe. Make sure you still have that engineering oversight. Having a way of documenting all this stuff, just like in most engineering projects, you need that kind of documentation for both, to show the deliverables as well as do it safely. So thanks, hope you enjoyed this one, and I'll see you in the next one.